is a bonus section of working with fractions. And why did I make a bonus section of working with fractions? So not many folks seem to love fractions. So I wanted to give us a quick go over of the rules we need in order to add, multiply, subtract, and divide fractions. That way as they come up as we go through this text, be it when solving an equation or graphing a line or finding a solution, we know what we're working with. And if you have any questions, feel free to comment under this video or send me an email. So, multiplying and dividing fractions is easier than adding and subtracting fractions, in my opinion. When we're first learning math in like elementary school, right, we learn how to add, and then we learn how to subtract, and then we learn how to multiply and divide. Well, with fractions, it tends to be the opposite. So when I'm multiplying fractions, the product of two fractions is a fraction whose numerator is the product of the numerators and denominator is product of the denominators. And multiplication is multiplication, so this is still commutative and associative, right? Properties of real numbers. So when I'm multiplying fractions, I multiply my numerators and I multiply my denominators. As long as my denominators are not zero, because again, we can never divide by zero, and that fraction mark kind of stands for division. So let's practice multiplying some fractions. If I have 4 times negative 3/7, it's important to note that 4 could be written as a fraction over 1. 4 times negative 3 is negative 12. 1 times 3 is 7. So I have negative 12 sevenths. 7 times 2 is 14. 3 times 8 is 24. Note that these both have a factor of 2 in common. How can I tell? Well, the numerators and the denominator are both even. So we need to simplify this to 7/12. If I have negative 3/5 times 4/9, that's going to be negative 12 over 45. I always like to keep the negative in the numerator. Technically it belongs out front. Negative 12 and 45 have a common factor of 3, so I've got to factor that out. If I pull out a 3, I've got negative 4 over 15. Last but not least, if I have negative 3/2 times negative 9/1, that gives me a positive 27/2. When we're dividing fractions, what we do is keep, change, flip. So KCF. I wish it was KFC, but it didn't work out that way. So to divide a fraction by another fraction, you multiply by the reciprocal. So we keep our first fraction the same. We change from division to multiplication, and then we flip our second fraction. So if I had 1/2 divided by 3/7, we would keep our first fraction the same, change from division to multiplication, and flip, or take the reciprocal, our second fraction. And that would give me 7/6. So let's work through a few examples. 5 divided by 2/3. So always when I rewrite that as a fraction, I keep my first fraction the same, I change from division to multiplication, and I flip my second fraction, which gives me 15/2. I don't know why I used 2/8. That's not in fully simplified form. Let's go ahead and simplify that, shall we? So I have 7/3 divided by 1/4. I keep my first fraction the same. I change from division to multiplication, and I flip my second fraction. 7 times 4 is 28, so I have 28/3. Again, I keep my first fraction the same. I change from division to multiplication, and I flip the second fraction. I have negative 27/20. Again, I multiply the numerators, multiply the denominators. Here, I keep my first fraction the same. I change from division to multiplication, and I flip the second fraction. I've got 2 negatives, so my product's going to be positive. 3 times 1 is 3. 2 times 9 is 18. 3 and 18 both have a factor of 3 in common. That gives me 1/6. Now, let's talk about adding and subtracting fractions. If two fractions are being added or subtracted, they have to have the same denominator. So if two fractions are being added or subtracted and they have the same denominator, you add or subtract the numerators and put that number over the original denominator. So if I had 2/3 minus 1/3, that means I've got 2 minus 1 over 3, which is 1/3. And you could think about that visually if that helps you. So let's say I got 2/3 of a pizza because it's circle and pizza's delicious. And if I was to take away 1/3, I'm only left with 1/3. If I've got 5/6 plus 2/6, that's going to give me 5 plus 2 over 6, which is 7/6. If I have 4/9 plus 1/9, again, you can always kind of visualize it if that's something that helps you. I've got 4 plus 1 over 9, which is 5/9. And if I've got 3/11 minus 6/11, I have 3 minus 6 over 11, which is negative 3/11. Where things get a little more complicated when it comes to adding and subtracting fractions is when they do not have the same denominator. So in order to get them to have the same denominator, we need to determine the LCD. Let me switch back to a better color. The lowest common divisor, or LCD, given two numbers A and B, is the smallest number divisible by both A and B. And we can solve these using factor trees. So first step is to write the prime factorization of each number. What does that mean? I think I got a little ahead of us. So friendly reminder, sidebar, that every number can be broken down into primes. 6 is 2 times 3, and I can't break 2 and 3 down any further. 15 is 3 times 5, and I can't break that down any further. So the first three primes, which are numbers divisible by only one in themselves, are going to be 2. 1 is not a prime number. If they told you that in high school, they lied, and I'm very sorry. 2, 3, 5, 7, 11, 13, 17, right? These are the first few primes, and there are infinitely many of them, so you always need a list. If I take a prime factorization of a number, that means I'm breaking it down into its unique list of primes, right? If I had 28, that'd be one reason I like to make a factor tree so I can see 2 times 14, which is 2 times 7. So its prime factorization is 2 times 2 times 7. That's what a prime factorization is. It means I'm breaking it down so I can write it as a product of primes. Then what we're going to do is write each number as a product of primes and matching vertical columns, and bring down the primes in each column. We multiply those to find the LCD. Okay, what does that look like? Let's take 12 and 18. 12 factors into a 4 and a 3. 4 isn't prime, so I'm not done. I need to write that as a 2 and a 2. 18 factors into a 2 and a 9. 9 isn't a prime number, so I have to break that down as a 3 and a 3. This is like, I think this is called the table method. So what I'm going to do first is write all the primes of 18. So I've got 2, 3, and 3. Now I have 12. I need to write all the primes of 12, matching primes vertically when possible. So I've got a 2, but then I've got another 2, so I've got to put that over here because 18 doesn't have a mate for that. And then I've got a 3. To find the LCD, we bring down the primes in each column. So that's going to be, our LCD is 2 times 3 times 3 times 2, which is 4 times 9, 9, 18, 27, which is going to be 36. So 36 is the smallest number divisible by both 12 and 18. There would be bigger numbers, right? If I was going to multiply 36 by any number, that would also be divisible by 12 and 18, but we want to find the smallest because it makes life easier to work with these numbers if we don't have really, really big denominators as we're adding them.